So hello guys, this is a function generator, and what this generator will be basically doing for in the case of FET amplifier is that it will be providing you with AC signals, and here you can vary the amplitude as well as the frequency of the input signals, and accordingly you have to get the voltage in the voltmeter that is inbuilt in the FET.
Make sure that your pulse width is set to minimum and your DC offset is also switched off.
Now, so the initial part is how to connect it. You connect this part here, and there is two other ends. The red one goes to the positive side of the voltmeter. Black one goes to the negative side of the voltmeter.
You can refer to your notes here. If you do that, it says you want to get 0.2 voltage and 1 kilohertz for your input signal.
Okay guys, so before varying the frequency and amplitude, make sure that you press this 20 decibel button. So guys, now first we have to set frequency into 1 kilohertz. So before setting amplitude, you have to set the frequency. Just make sure, don't set amplitude first and then set the frequency. Okay, now we have to take 1 kilohertz. So we'll increase the range to, let's say, yeah. So this will do it. Like you might not get the proper 1 kilohertz. Some variation will be good. Now what you have to change is you have to keep this constant. Don't touch anything now. The only thing you are going to change is the amplitude range. The way you have to change the amplitude is that here it should show 0.2 volts. Now we'll increase it. So as you can see, here we have gotten 0.20 volt. Now our input signal, the first part of our experiment is done.
Alright, you can notice that there is a very minuscule error in your voltmeter sometimes, and that shouldn't be an issue. Now, our task is to connect this circuit as shown in your figure. Make sure that you memorize it, yeah? Now, you're supposed to connect these resistances and these capacitances. Now, the work is easy for you because the capacitances and resistances, where it says the value of the capacitance or the resistance, such as 1 microfarad and 1 million ohms in this case, or 1 mega ohms, these resistances are connected internally. So you don't need to connect wires from here to here. What you need to do is connect resistances in cases where it's not mentioned how many ohms or how many farads you need. So we're going to do that. And so let's see. Your diagram says that your RS needs to be 330 ohms, but unfortunately we don't have a 330 ohms resistor here. So we're going to use the closest one, which is a 470 ohms resistor. So that we'll do this. Similarly connect RD and CS, and we're going to skip to the part where they are all connected. Alright, now you can see that I have connected these resistances and the capacitances which had not been connected. Again, the ones which have no label which says how much ohms or how many farads they are. So you can see that I connected this CS capacitance to this 10 microfarad one, just like in the figure which says 10 microfarad. Now, next what we're going to do is take your input terminals from your function generator or your signal generator and give it the input. Which you have set to be already 1 kilohertz and 0.2 voltage. So we do that here. Alright, now we're almost done. We need to do some more things. You need to make sure that your VDD is connected. So we're going to take a positive voltage from here and put it onto VDD. And up next, we're going to take this one and connect it to the ground terminal, which is going to be here. Now since RS is already connected, you can choose to connect it here or here because they are all shorted, so that doesn't really matter. You can connect it either here, or you could have connected it here too, and that would be perfectly fine too.
Basically all these terminals are grounded.
They're all shorted together. You could connect it here too, but that's besides the point. Now that you have connected everything, you want to take the output voltage, right? So that is connected across the capacitance C out, so this one, and the ground, so this point. So you're going to connect the voltmeter in such a way that it takes the output reading from here. We're going to do that. Negative goes to the ground, and positive goes to the V out terminal. All right. Now we have set our setup, and now we're going to take the readings. Okay. Up next, we are supposed to take the readings, and how we are going to take the readings is we are going to vary the frequency in this signal generator, and then we are going to see the corresponding voltage in the output, across the output basically. So we know that the input is set at 0.2 volts. That's not changing. This is still 0.2 volts. We're going to change this, and we're going to notice a change in voltage, output voltage. Let's do that. So we're going to start from 10 hertz, and we're going to go up until 1 million hertz. So we're going to do it in increments of 10, and then increments of 100, and then increments of 1000, and such on. So that will be easy for us to plot on a log table. Log graph. So let's do that. We'll start from 10 hertz. Note down the corresponding frequency and the corresponding voltage onto your table, and calculate the gain using this formula. Note that this isn't the same result because this FET is a different FET, so results might vary. What you need to make sure is that as you increase the voltage, you're going to notice a plateau. That is a very little change in your output voltage as you change your frequency rapidly. So it's going to start very low, and it's going to increase, and then it's going to stay stable for a while, and then it's going to come down again. Let's do that.
This is how the graph of a function basically plot between the gain and the frequency will be. So basically the values will first increase to a certain point, then it will be a constant value, and then it will decrease.
So now that you have diligently plotted out your frequency versus voltage, you calculate your gain, and then you plot your gain versus frequency curve, right? And then you see which is your maximum gain. So in this case, here is the peak. You're going to draw a horizontal line which corresponds to some number, which is 5.8 in this case. And then you're going to calculate AV max, which is 5.8 divided by √2. And that will give you some number. Now that number you need to again plot horizontally across your frequencies. So you're going to do that. And what you're going to notice is that it's going to intersect your curve at two different locations. From those two locations, you're supposed to drop down to perpendiculars onto your frequency, basically zero gain frequency line, right? And then you're going to note down these frequencies. And when you subtract those two frequencies, that is FH minus FL, you're going to find the bandwidth. And that concludes the experiment. Thank you.